Okay, so I think I'll be covering uh, chapter 6 and some of the important things that we learned from it. So, chapter 6 was mainly about, sorry, uh, chapter 6 was mainly about like probabilities and sampling, like how we did in our assignment. Uh, Covered different types of sampling, like simple random samples, taking samples from different groups. We started out the chapter talking about like population census and what a sample is. So these are important terms, I guess. I'll say them. Population is just like your entire, like what you're pulling from. So I guess if you were using the United States as an example, population would be, uh, the entire population, everyone in the country. A census of that, which they do like every 10 years or whatever, is a study from all of those members of the population. Uh, this sort of census is like, okay, what I was trying to say there is censuses are good because it gives us like the data that we want. It's just really hard to pull off, so we don't do them a whole lot. And that's why we have samples, because you take a small sample from your population of like, in our homework example, they said 100 people. You take a small sample of 10 of those people, and you hope that the method you took accurately represents that group. Um, and then there's different types of samples. Of course, there's a lot of different types of samples. There was non-probability sampling, where it the subjects are chosen by your researcher, and then you have probability, where they're just randomly selected, and then you have convenience, which is, I think, more oftenly not going to be used just because of whatever constraints your study has. Convenience sampling offers workarounds because you don't always have a million years to conduct your study, or you don't have the money, so you can't go out of your way to question so many people. All right, and I guess now I'll go over a bit of the assignment that we had. So the first part, of course, just goes over our population, which is, of course, the entire group and their SAT scores. And sample one, which was very easy, it was just the first 10 people. This was, sorry, let me look for my page. So that was non-probability sampling. That was just picking out a very specific group, and we got the average from that group. This is not a very great method, just because we didn't really get to see. We only got data from like one particular group out of our population, which in this case was the lower scoring group, the first 10 people, which wouldn't be an accurate representation of our data, so we don't want to use that. Our sample 2, the simple random sampling with sample size, where we randomized this, was a little better, but again, another problem came up where, based off your randomization, I mean, you could have gotten unlucky and gotten numbers that you could have gotten more people from one end of the spectrum than from the other. So maybe you got a lot of, like in my example, I got a lot of people in like the 30s. So that's where the average was leaning towards. So again, not a great accurate representation of the actual data. And it got a little better with 50. It got closer to the actual average. But again, the problem with this comes back to convenience. Um, you're you're pulling from half of your sample size, which out of 100 may not seem like a lot, but if you were to do that out of, let's say, all the students at Utah State, half of them, questioning half of them would be really hard to do. And it's not even the most accurate. So we can just move on from that one. Our fourth one, which was the systematic random sampling, was very good because we got a very even distribution of people we were pulling data from, because our data was broken up into 10 groups ordered from lowest scoring to highest scoring. So we could pull the middle number from each of those groups, like the middle, like we started on 5 and went to 15 and to 25 and 35 and so on. Because of that, we were just getting the most evenly spread out, just best possible polling, like showing for like, oh my god, I'm blanking on the words here. The systematic random sampling worked out better just because there isn't any like left or right leaning, like it just is dead smack in the middle. It's where we want it to be, and it's a pretty accurate average for the population size, and we only got 10 people out of 100, so it did really good. Now the fifth one, which was kind of complex, which was called the stratified random sampling, where we divided it again into 10 groups and took a random number from all those 10. It was close, but it still wasn't quite as well, and I think it just boils down to the randomization. You just get unlucky and you get like for me, for example, I was getting like 14 and then 21, which aren't that far apart. Like 14, its score was 1109 and 21 was 1137, whereas I could have gotten a different result, like 30 in that same group, and it would have been 1154. So, it just, the randomization there throws it off even more, and you could get lucky, you could get unlucky with how accurate your sample was there. So those were the 5 groups that we used, and of course, at least for me, the systematic random sampling was the best. I got an average of 1,200, which I hope everyone got. And yeah, just because its average was closest to the actual average of the population, so of course you'd want to use that in multiple cases. Then what else? And yeah, I think that would be, for the most part, the best to use out of all of these, because something stood out to me about like just the randomization. It's random. You don't really have much control over your sample, so you could just get unlucky, and anytime you do a random survey, you might only get one part of your population that actually answers that survey. So having a stricter construct like the what's it called? Like the systematic random sampling, where your start number is random, but the rest is evenly distributed and is done systematically, of course. Having it be set up like that, it forces the diversity for your sample. So you can get, with a really small sample group, like a tenth of your original size, you can still get fairly accurate data, which, you know, is a good thing and ought to be done more. But again, it could be hard because applying that into the real world, you know, could be hard. I mean, and we talked about, in this chapter, we talked about a lot of other things. Some of the other different types of sampling and stuff like that. Talked about like phone sampling and stuff, and of course there's biases there because telephone surveys have like low response rates and stuff like that, just because people, either if you're in a lower income household, or you have just like, you don't have a landline, you know, you're less likely to answer. And then, yeah, I think for the most part that sums up everything we've talked about so far with probability and sampling in chapter 6.